This video is over lesson 84, Algebraic Terms, and is for my 7th grade math class. So ladies and gentlemen, just a quick review here. We've got our math pyramid that we've talked about off and on throughout the year. So we start at the bottom with addition and subtraction. Those are the first things we learned when we got to school, assuming that we already learned how to count. So addition really is just repeated counting. So 3 plus 5 means start at 3 and then count 5 more. Or count up 3 and then count 5 more. So subtraction is the inverse of that. It undoes that. It counts backwards. If we have repeated addition, so if we repeatedly add up 3 plus 3 plus 3 plus 3 plus 3, we can rewrite that as 3 times 5, or 5 groups of 3. So multiplication is just repeated addition. Then the inverse of that is division. So instead of having groups of things, we're dividing things up into groups, or looking at how much would be in each group if it was nice and even. If we repeatedly multiply, so 3 times 3 times 3 times 3 times 3, we can rewrite that in a smaller form using exponents. So 3 to the 5th power would give us the instruction to multiply 3's, and then the exponent 5 would tell us how many times we're multiplying those 3's. The inverse then of exponents are roots. And then finally, at the top of our pyramid, we find our grouping symbols, our symbols of inclusion, that we usually just label as parentheses. The most common symbols of inclusion, the most common grouping symbols are parentheses, and so they get to name the group. But we have parentheses, we have braces, brackets, and absolute values that all fit into this category, as well as some other things called functions, where there's something that you have to do before you can find another answer. So for example, fractions often have what we call invisible parentheses, or what I call invisible parentheses, because you have to figure out what the numerator is before you do the division, because fractions mean division. So this is our order of operations. And so starting at the top and working our way down, when we try to solve equations, we actually start by undoing the weakest stuff and work our way up to the strongest stuff. But today we're looking at this pyramid for a different purpose. We're looking at it for the purpose of considering terms. So in the math pyramid, the stronger operations are on top. The 3 top layers of the pyramid are strong enough to bind numbers and variables together as a thing that in algebra we call a term. And so you see I've got these in green. Green means go ahead and combine them as one term. Addition and subtraction, being the weakest operations, only separate terms. So I have this in red for stop. So when you get to addition or subtraction, stop, that's the end of that term. So after the plus or the minus will be a new term. So the strongest operations bind them together as one term, but the weaker operations, addition and subtraction, separate them as terms. Many terms are also what are called monomials. Monomials, though, cannot have variables and denominators or radicals. Also, when monomials can be grouped together in parentheses, if something were multiplied by things in parentheses, then the things in the parentheses would not be considered part of the monomial. Don't worry too much about this. You'll learn more about it in the future. Okay, so I just for full disclosure, there's a bit more to the definition of a monomial than we need to worry about today. And so that's what this big thing in parentheses here is really for, is just to say, hey, there's more to it. So just kind of have that in the back of your mind, that we are going with kind of a simplified definition of monomial for today. So a monomial basically is a term. So some examples of monomials. 2x would be a monomial. So remember that multiplication is strong enough to bind things as a term. So multiplication works. For that matter, I could have no numbers and just all variables. A, B, C would be a monomial. You could also have, let's go with, let's say d, now let's say 1/5 d squared e that would be a monomial. So it's all multiplication. We got an exponent in there. The exponent there is strong enough to be grouped with the term. So that 2 is a part of that term there, is part of that term with the d. You could have a fraction. Now remember what we said in the parentheses here. You can't have your variable in the denominator. Numerators are okay. So you can have x in the numerator, you just can't have x in the denominator. I could just have, let's say, n cubed. So again, exponents are fine. For that matter, it is possible just to have a single number or a single letter be a monomial. So -9 is a monomial. If I were to take the cube off of n here, n all by itself would just be a monomial as well. So mono means one. So each of these is just one term. So down here, 2 monomials that are added or subtracted. So remember, addition and subtraction separate terms. So they're also going to separate monomials. So 2 monomials that are added or subtracted are called a binomial. So bi means 2. So for example, I could take my 2x from up above. I could take my ABC from up above. And if I add or subtract them, this is a binomial. Likewise, I could take my 1/5 d squared e. I could take my x over 3. And as long as I add or subtract these, that is a binomial. And then finally, I could take my n cubed and my -9. Now here's the thing. I chose a negative on purpose here because as we get higher and higher and higher into mathematics and into algebra, we start to kind of combine the minus and the negative sign together in a way where instead of writing plus -9, I can just write -9. And then we know to treat this minus as if it was a -9. Three monomials that are added or subtracted are called a trinomial. So I could have, from up top there, I could have my 2x plus the ABC there, and then let's say minus my 1/5 d squared e. And that would be a trinomial. There's one term, plus, says stop. That's the first term. Moving on to the next one, ABC minus stop. That's the second term. And then 1/5 d squared e would be the last term. So 3 terms, that's a trinomial. Likewise, if we kind of buddy up with these up top, I could have my x cubed. I could have minus, let's just go with n this time. We'll modify that slightly. N, and let's say plus 9. That would be a trinomial. Any number of monomials added or subtracted are called polynomials. So poly means many, but that's kind of deceptive because it actually, each of these monomials is also a polynomial. So even though it doesn't have many terms, it actually is a polynomial. So each one of these is a polynomial. Each of these binomials is a polynomial. Each of these trinomials is a polynomial. So any number of monomials added or subtracted, or even just one by itself, is called a polynomial. So I have a bunch of terms here, a bunch of different monomials. And so monomials have a number and a variable and a kind. And so we're going to examine that right now. So first of all, the number should be easy to find most of the time. So obviously here the number is 3. The 2 exponent does not count. Exponents don't count here. So it's just the 3. So the variable or variables here, are actually, we have an x squared. So the square tells me there are actually two x's that are there. So it's not just a single x, it's actually two x's that are there. And so what kind of term is this? We would call this an x squared term. Over here, this one's actually a little deceptive, because if you're looking for the number, you might be tempted to say there is no number. But actually there is. Because remember, 1 times anything is itself. So 1 times x equals, and leave a space there because I have a reason for it, is x. So that means anytime that you've got a variable without a number in front, it's actually an invisible 1. Now in this case, it's a negative x, so that really just means it's a negative 1. That's our number out front. So our number here is a negative 1. The variable, well, the only variable we see there is x, and so this actually is an x term. And it's important to note here that these two are not the same kind of terms. And x squared is not the same as x. So these are not the same. Next up, negative 4. Obviously the number is right there in front of us, negative 4. So our variable here, well, this time, well, none. We have no variables. So because there are no variables, the word variable means able to vary. So if we consider here, if I were to put different numbers in for x and then solve, so if I put 1 in for x, 1 squared would be 1, times 3 would be 3. If I put in 2, 2 squared would be 4, times 3 would be 12. If I put in 3, 3 squared would be 9, times 3 would be 27. So depending on what number I put in here, the answer can vary. Likewise over here, depending on what I put in, I get different things out. If I put in a 1, I get out a negative 1. If I put in a 2, I get out a negative 2. If I put in a negative 3, I get out a positive 3, because the two negatives would cancel. So with variables, we get varying results. But here with negative 4, it doesn't matter what x is. If x is 9, negative 4 is still negative 4. If x is 27, well, negative 4 is still negative 4. Since there's no variable there, its value never changes. Or we could say that its value is constant. This is a constant term, and I didn't quite have room to write that all. So this is a constant term. A number all by itself is a constant term. All right, with those basics out of the way, the next few should move pretty quickly. So our next one here is just a y all by itself. So remember, if it's all by itself, it's really an invisible 1 there. It's really an invisible 1. So 1y is y. So it's an invisible 1. What kind of variables do we have? Well, we have a y, that's all we have, which means that this is a y term. Number here is a 5. Variables, we have an x and a y, which means that this is an xy term. And finally, to finish it off, we have a 7 for our number, we have an x for the variable, and we have an x term. So, like terms are terms that have exactly the same variable, which includes any exponents on the variables. Only like terms can be added and subtracted with each other. Unlike terms are left with separated by addition or subtraction. Actually, don't need a with there. Left separated by addition or subtraction. So like terms have exactly the same variables. They have exactly the same variables. So if we go back up to our chart here, if you look at the kind, they got to be the same kind. So I've got an x squared term, an x term, a constant term, a y term, an xy term, and an x term. Well, it turns out that this and this are the same, which means that negative x and 7x are actually like terms. From our chart above, those are the only two that are like terms, which means that you actually could add or subtract those together. And so if I had a negative x plus 7x, well, in that case, this is really a negative 1 plus 7. So since they have different signs, we'd subtract. So 7 minus 1 would be 6. Since the bigger one's positive, it'd be a positive 6x. So notice that it starts off with an x term and an x term, and it ends with an x term. It can be helpful from now on to think of the minus sign as really meaning plus and negative. We've already talked about that a little bit. So combining like terms, only the things that have the same variables can be added. Only things that have the same variables can be added here. So if I take a look here, I'm looking at the variables. So looking at the variables, this has an x, which makes it an x term. No variables makes that a constant term. No variables makes that a constant term. So I can combine the two constant terms, but the x term is going to be all by itself. So I'm going to copy my x term. Nothing's going to happen to that. And then I have a plus 3, so we're going to think of that as a positive 3. And then a minus 1, so we're going to think of that as a negative 1. So 3 plus a negative 1, well, they have different signs, so subtract them and the big guy wins, plus 2. Now, since this is an x term and that's a constant term, they are not the same. That's as far as we can go. Some of you are going to be tempted to make this 5x, and that is wrong. That is wrong. You cannot do that. So whatever it's going to take for you personally to remember that, you got to do it. You got to write yourself a post-it note and say, no, don't combine these, not like terms, whatever you got to do. But if they don't have the same variables, you cannot add or subtract them. So 3x plus 2 is just 3x plus 2, nothing we can do there. Next one, we're looking for just the variables to start. So x, y squared, x, y squared. Do those match each other? Yes, they do. And you've even got to check the exponent. Is the exponent on the correct variable? Well, yes, it is. Remember that this is really a hidden 1 in front of this. So what we have here is a negative 3x squared plus 1xy squared. Well, negative 3 plus a positive 1 would be a negative 2. And then it is still the same term, the same kind of term. So since it was xy squared, it's still xy squared. Down here, this is an x term, a y term, an x term, and a y term. So I can combine my two x terms, I can combine my two y terms. Remember that anytime we're missing a number, it's really a 1 out front. So for my x terms, I have a 3x plus a 1x. Well, 3 plus 1 is 4, and it's still just x. This is another common mistake that students want to make. They want to turn that into x squared. If I come over to my dry erase board here real quick. X plus x is just 2x. Okay, so think about it this way. Repeated addition will change what we are multiplying. Repeated addition is multiplication. So repeated addition will change what we're multiplying. So if I make this a 3x plus 7x, repeated addition, so if we add up 3x's with 7x's, that's a total of 10x's. It's when we multiply, repeated multiplication changes exponents. So that's not what we're doing today. So the exponents are not going to change. If it's an x term, and that's an x term, we can add them, and it's still an x term. All right, so back to that problem. So I've added my 3x with my x. Now I need to add my y terms. So this is a positive 1y. This is a negative 1y. So positive 1 plus a negative 1 is actually, well, 0. So 0y, so little thinking here. If we think about 0y, well, 0 times anything is 0. And then if I take my 4x and I add on that 0, well, 0 plus anything, the plus 0 just disappears. So when combining like terms, if we ever get a 0, then that term disappears. So this is just 4x. So y, 1y minus 1y equals 0y equals 0. So 0 as a term disappears. Which is why it's just 4x. So our y's disappear this time. All right, last one. I have an x term. I have an x squared term. No variable means this is a constant term. An x squared term, an x term, and another constant term. So I'm going to actually kind of put these in order a little bit. I'm going to start with the highest exponent. So I'm going to start with the square. So I'm going to put my x squareds together. So I got 2x squared, a positive 2x squared, and then a positive 1x squared. Well, positive 2 plus positive 1 is 3. And then remember, it's staying x squared. When we add or subtract, that exponent, that variable does not change. It's still an x squared. I'm going to move down to my x's now. So I've got a 3x, that's a positive 3x. And then this minus means we're going to treat this like a negative. So a negative 1x. Or you can just think of it like a minus 1. So 3 minus 1 is 2. And it's still an x term. And then finally, I'm going to finish off with my constants. So a plus 4 and a minus 1. So 4 minus 1. Well, it's a positive 3. And there it is. So at this point in time, ladies and gentlemen, I'm going to ask you to go ahead and grab your books and open up to page 583. 583. Pause the video if you need to. And we're going to look at the practice problems together to finish off this lesson. So, directions. Describe each of these expressions as a monomial, binomial, or trinomial. So A, look for the minuses and the pluses. Remember, we had those in red on front here. The red is saying stop. You've come to the end of one term, and you're about to move on to the next. So x squared minus stop. So x squared is one term, and then y squared will be the second term. So if there are two terms there, then this is a bi for 2, binomial. B, 3x squared minus stop. So 3x squared is your first term. So minus 2x minus stop. So 2x is my second term. Well, minus 1. So minus 1 must be my third term. Well, 3 is tri, so it's a trinomial. Letter C, a negative 2x cubed y z squared. Well, we never stopped, which means that all that's just part of one term, one monomial. And then finally D, a negative 2x squared y minus stop. So that negative 2x squared y is my first term. Minus 4xy squared. Oh, that must be my second term. So two terms means binomial. E, state the number of terms in the expressions in A through D. E seems a little silly, but whatever, we'll do it. So A it's a binomial, so it has 2 terms. B, trinomial, has 3 terms. C, being a monomial, has 1 term. And finally, D, being another binomial, has 2 terms. And then I'm going to go ahead and split that. I'm going to come up here for F. So F, collect like terms, show your steps. Now collect, your book likes to use the word collect. I like to use the word combine. So just be aware of that. Pretty much everything I've ever seen and the way I learned it said combine like terms. Collect like terms is the same idea, so it doesn't really matter. Just be aware that you may hear both things and they mean the same thing. So collect like terms, combine like terms, same thing. F, I'm going to copy the problem down. 3a plus 2a squared minus a plus a squared. And so let's go ahead and combine these. I like to start with the highest exponent stuff. That's kind of preparing you for algebra a little bit. So I'm going to start with my a squareds, then I'll move down to my a's. So I got an a term, a squared term, a term, a squared term. So this is positive 2a squared. This would be a positive hidden 1 a squared. So 2 plus 1 is 3 a squared. Down here I've got a positive 3 minus 1a. So 3a minus 1a. Well, 3 minus 1 is 2. Positive 2. A. G. G says 5xy, so that's an xy term, minus x, so that's an x term, plus xy, so there's another xy term, and then minus 2x, there's another x term. I'm going to start with my xy's. So this is 5xy, a positive 5xy, and this is plus 1, hidden 1, xy. So 5 plus 1 is 6xy. Now for my x terms, this is a minus 1, so a negative 1x. This is a minus 2x, so negative 2x. So a negative 1 plus a negative 2 would be a negative 3x. So 6xy minus 3x. And again, since these are not like terms, that's as far as you can go. Again, some of you are going to be tempted, resist it. Some of you are going to be tempted on problems like this to go 6 minus 3 is 3 and then have the x cancel out. That is not how this works. Okay? If you do that, it is wrong. It is wrong. If you were to actually plug some numbers in to this and then try simplifying it the way I just described and plug numbers in, you will find you'll get 2 different answers. So it will no longer be the same thing. This is as far as we can go right now. So, all right, H. H, we have a 3 plus x squared plus x minus 5 plus 2x squared. So constant term, x squared term, x term, constant term, x squared term. I'm going to start with my x squareds. So I have a plus 1x, so positive 1x squared, and then a plus 2x squared, so positive 2x squared. So positive 1 plus positive 2 makes a positive 3x squared. Now I'm going to move on to my x's. Well, that was my only x. I don't have any other x terms. So it's just going to be all by itself as a plus x. And then finish it off with the constants. So I have a positive 3, and then minus 5 is like a negative 5. So 3 plus a negative 5, well, that'd be 5 minus 3 would be negative, or would be a 2. And then since it's a negative that's bigger, negative 2, which we'll just write as minus 2. So 3x squared plus x minus 2. And then finally I. For I, we have 3 pi plus 1.4 minus pi plus 2.8. So for this one, it's a little odd in that pi is not actually a variable. It actually is a constant. It has a specific value. However, because it's written as a symbol, we're going to treat it just like we would a variable. So even though it's not a variable, we're going to treat it like a variable because it's a symbol. So we're going to treat this like a pi term. This will be a constant term. This will be a pi term. And this will be a constant term. So we have 3 pi's minus a hidden 1 pi. So 3 minus 1 is 2 pi. And then a positive 1.4 and a positive 2.8 means, well, add those together. 1.4 plus 2.8 is a positive 4.2. Since positive, it'll be plus. So 2 pi plus 4.2. And that, ladies and gentlemen, is the end of our lesson.